Now let's graph some functions. When I see that 1/2, I immediately know it's a decay function. And all of these are going to have a horizontal asymptote at y equals 0. So you pretty much know what it looks like before you start. You're going to have some kind of function that looks like this. Okay? So I think the best thing to do is make a table and plug some numbers in. So a lot of times -2, -1, 0, 1, and 2 will be good numbers to plug in, but that kind of depends on the problem. So maybe they're good, maybe they're not. So you have 1/2 to the -2nd. So that -2 flips it and squares it. So it's going to be flip the 1/2 to 2 and square it. That's going to be a 4. 1/2 to the -1st. Flip it to the first power. That's 2 to the first, which is 2. 1/2 to the 0 power. Anything to the 0 power is 1. 1/2 to the first is 1/2. And 1/2 to the second power is 1/4. So I'm going to cheat a little bit and use graph paper. You're going to have to draw your own grid. So you don't have to go 10 by 10, but that's going to be a good place for me to start. -2, 4. -1, 2. 0, 1. 1, 1/2. And 2, 1/4. So you can kind of see how this looks. It's going to look like a decay, just like we thought. Feel free to do more if you like. Don't forget about your horizontal asymptote. You could even draw it in if you want. I noticed on the last test, several people didn't seem to know what a horizontal asymptote should look like. And so you should probably think about drawing that in at y equals 0 for your horizontal asymptote. Give the domain and the range. So domain, remember what domain is. Domain is what x numbers you're allowed to plug in, and there aren't any problems. So domain is going to be all real numbers. If you squash that graph onto the x-axis, everything's going to be covered. Range is what are the y numbers going to be. Y numbers will never go below 0, so it's going from 0 to positive infinity. So this next one, it looks like it's going to be growth because of the 3, but the negative sign is going to flip it. So it is a growth problem, not a decay, but it's going to be growth with a flip. So normally growth would look like this, but this one's going to be flipped, so it's actually going to look like this. I think it's smart to know what it looks like before you start. So I'm going to plug in some, maybe the same numbers. And I have -3 to the -2nd power. So that's negative, and then you're going to flip the 3 and square it. So that's -1/9. And -3 to the -1st. So negative, flip the 3 into the -1st. Sorry, not negative anymore. -1/3. -3 to the 0 is going to be -1. -3 to the first is going to be -3. And -3 to the second is going to be -9. Okay, notice I'm not squaring a negative number. This negative isn't really attached to the 3. You're taking the exponent on just the 3. So it's 3 squared is 9, and then the opposite of that. So really we shouldn't have said -3. We should have said the opposite of 3 to the x. So again, let's just copy. I'm going to copy and paste this graph paper in here. -2, -1/9. -1, -1/3. 0, -1. 1, -3. And honestly, guys, sometimes graph paper is not easier to use because it's so small. So really, ideally, I'd draw this much bigger, or if you used your own, if you just drew it by hand, here's the asymptote. If you just drew it by hand, you could kind of size it better. So sometimes graph paper is a disadvantage. So I see my asymptote, my horizontal asymptote at y equals 0, and I see my flipped growth graph. This one is a growth, and this means it's shifted to the right 2. So if you're smart, you'll notice that it's shifting right 2, and you'll shift your numbers to the right 2 and see that these numbers here are going to be easier for us to graph. So 0, 1/9, 1, 1/3, 2, 1, 3, 3, 4, 9. Those are going to be the easiest ones. Now, if you wanted to do negative 1.04 and negative 2.01, those are going to be really hard to graph. We still have that horizontal asymptote at 0. Oops, make sure that your growth function doesn't cross. We're going to look something like that. That's a growth function that's been shifted to the right by 2. Okay, so the domain is going to be all real numbers again, and the range is going to be from 0 to infinity. That will not always be the case. Now, I think I forgot to do the last one, so let's go back and hit the domain and the range. Domain, all real numbers. This range is different because it goes from negative infinity to 0. It's on the bottom half of the graph. So example 3, C. Okay, this one is a growth function. I can tell by the 3, and it's going left 2 and down 2. So if you imagine what this graph looks like, I know it's growth, but it's normally it would be like this, but it's shifted 1, 2, it's shifted to the left and down. So I don't know exactly, you know, this part's too vertical, I suppose, but we're definitely shifting it left and down. So it's going to look something like that. So again, if you're smart, you'll notice that this graph is shifted to the left 2, so it would be wise to shift your numbers to the left 2. These are going to be good ones to use. Otherwise, you'll get some numbers that, you know, you can deal with, but they're kind of big, and you'd have to change your scale, and that's fine. If you're drawing your own graph, you can make it go as high as you want. You can go up to 79 if you want, and that's fine. But I think if I'm using this graph paper, I'm going to shift my numbers to the left. Negative 4, comma, negative 1 and 8/9. It's about right there. Okay. Now notice when we are shifted down 2, that automatically tells me there's going to be a horizontal asymptote at y equals negative 2. So I could go ahead and draw that in right now if I wanted to. I know there's a horizontal asymptote there. So go back to the chart. Negative 3, comma, negative 1 and 2/3. Negative 2, negative 1, negative 1, 1, and 0, 7. And so there's my growth equation. Domain, all real numbers. Range, it looks like it's going, remember, you're squashing it onto the y-axis, so it's going from negative 2 and up. So negative 2 to infinity, from negative 2 to positive infinity.